Okay, let's start. So good afternoon, everyone, and welcome to the AIST MENA Safety webinar. Our theme today is From Insights to Action, Translating Safety Knowledge into Proactive Risk Reduction. My name is Manal Al-Badawi. 16 years ago, I have joined Borouge as an HSE engineer and have since progressed to my current role as ESG and Sustainability Manager at EMSTEEL. I am also a member of the AIST MENA subcommittee. It's my pleasure to moderate today's session with such an esteemed group of speakers. Today's webinar brings together industry experts to discuss how we will move from safety insights to real action, focusing on process safety, operational risk reduction, and building a strong safety culture across our organizations. As the session includes multiple industry participants, please take a moment to acknowledge AIST antitrust policy. Please avoid discussing any sensitive commercial information, including pricing, costs, market strategies, our customers or customer-specific matters. Our discussion today will remain at a high level, focusing on safety practices and industry insights. Before we start our agenda for today, just a few quick housekeeping notes. Please keep your microphones muted unless you are speaking. You may submit your questions at any time using the chat box. To ensure smooth connectivity, we kindly ask that cameras remain off. Each speaker will have up to 25 minutes, including questions and answers. Please note that the session is being recorded. Here's a quick overview of today's agenda. We will start with the 4 expert presentations. If time permits, we shall take more questions before the closing. I will also help manage time to ensure we stay on track. Let's begin with our first speaker, Ahmed Al-Jadidi, Director of HSE at EMSTEEL. Ahmed Al-Jadidi leads EMSTEEL Group HSE function, driving safety strategy and culture transformation through the Aman Journey to Zero Harm program, with a focus on leadership, accountability, and behavioral safety. Today, Ahmed will be sharing insights on achieving safety excellence, Aman 2.0. Ahmed, the floor is yours.
So thank you, Manal, for the introduction, and thanks for all joining the today session. I am pleased to share our journey on achieving the safety excellence through the Aman 2.0. And this is not just a program, it is a continuous journey to build a strong safety culture across our organization. So we start with Aman 1.0 in 2018 and 2019. At that time, our focus was mainly on the system and the compliance. So then we moved to the Aman Program 2 in 2023, and now the focus is bigger. We focus on the culture and the leadership and the technology. So because the safety is only about, it's not only about the role, it's about the people and the behavior. What is the main key initiatives that we covered during the Aman program? So under the Aman program 2.0, we focused on 5 key areas. The first one, the risk management, which is we focus on the strong focus on the serious risk and also the serious injury and fatality prevention. The second, life-saving rule and just culture. So we set a clear rule and fair accountability, encourage reporting without fear. The third key initiative, digital transformation. So the MyCheck system has been updated to make it very friendly, easy to use for all our employees. Real-time dashboard in MyCheck. So what we did, we have integrated the personal health and safety dashboard where they can download all the safety metrics for their day-to-day use. Also, we cover the digital management of change. The fourth key initiatives, the leadership engagement. The management, which is covering the management visible leadership and regular interaction with the shop floor levels. The fifth key initiatives, governance and strengthen. So the clear rule for the people, how to, it was set on how to work safely and what are their roles and responsibility. Also, better audit and the inspection and the contractor safety improvement as well. Going to the safe prevention. So we identified that 29% of incidents had serious injury and fatality potential. So we changed our approach. We focus on high-risk activities, and risk-based toolbox stock was implemented, and the critical control verification checklist, as you see down on the screen, has been implemented to make sure all the controls are relevant, preventing the theft. A clear investigation process as well. So we also introduce this BSIF flow into the MyCheck system. So the people will using this workflow, and automatically they could identify the incident as is it safe or not. Also, we distribute the booklet guidance for all the workers. So this will help us to focus on what matter most for us to improve the safety culture. Going to the life-saving rule and just culture. So we update our life-saving rule. More importantly, we introduce just culture. So for not to blame, but they have to be fairness, and encourage the people to speak up. So the people will not have the hesitant to speak up and to raise these such rules or the violations. And also we introduce the recognition for the good safety behavior as well. We trained more than 3,000 employees and the contractor. So the good result that it's gained after we had the training, better awareness and engagement from the employees and the contractor, and better awareness as well. Digital transformation. So we digitalize the process. So the management of change process, that we digitalize it, and the dashboard and tracking system for approval process with the relevant stakeholders. So the benefit of this digitalization, faster approval and better visibility, and improve the decision making. So this reduce the delays and improving the coordination between the stakeholders. Safe system of work. So we improve our permit to work system, and we introduce the unification of energy isolation procedure. So electrical and the mechanical, it was unified to be on one procedure and one system. Also, we have a clear process for all types of energy. So we ensure that the training it's provided for all of the people, and we conduct an audit, and the leadership support as well was involved. Leadership workforce engagement. As you see here, we have our group CEO and the top management. So the safety starts from their side. So the safety will start with the leadership, and we keep focus on the visible leadership ship, open discussion with the shop floor levels, and also we reward and recognize the safe, the better, the people who's acting safely and behavioral. Also, employees are not just following the safety, they are also driving the safety improvement. So whatever we improve it, our people, they are not just to follow it, they are implementing it as well. The governance and accountability. So we strengthen our governance, regular health and safety environment meeting. So this HSE meeting, it is conducted among the executive level up to the operation level. Clear accountability and structured inspection as well. So the safety now, it's reviewed at all levels. And the good things, it's owned by the operation. It means that they leading the HSE monthly meeting by themselves. So each department from the operation, they start to lead the HSE meeting. It's not the safety department. As a result and impact, we saw there is a strong improvement here. So as you see here in the screen, we have the total recordable injury frequency rate, which is reduced significantly. And we increase by encouraging the people to raise the near misses reporting. And also the hazardous reporting, it was increased as well. 100% of the training, it was completed based on the training need analysis. And the great also that we have achieved zero non-conformities from the regulatory or the third-party audit that has been conducted into the site. So due to this result, we had received the Safety Excellence Award from the World Steel Association. As you can see in the picture, that our group CEO is receiving it. So it shows that the people are more engaged and the system is well effective and working. So what is our key learning here? The ownership is better than enforcement, and the leadership drives the culture, and the digital tools support, but the people make the difference. So last but not least, in the future, we are planning to implement the AMAN program 3.0, and the focus will be on predictive analytics, AI-based risk insights, and smart systems such as lone working devices, GPS tracking of individual. At EMSTEEL, we believe that the safety is not only about the system or the rule. It is about the people, the leadership, and the ownership. So our journey, inshallah, will be continuing. And together, we are moving towards zero harm. Thank you for your time, and I am very happy to take any question if you have.
Ahmed, I have a few questions. Okay. Ahmed, AMAN 2.0 clearly goes beyond compliance into culture and leadership. What was the biggest challenge in shifting from a rule-based to a behavior-driven safety culture?
What is the big challenge that we say again, Manal? Can you repeat the question again?
Yes. What was the biggest challenge in shifting from a rule-based to a behavior-driven safety culture?
Yeah, the big challenge is that's what we are facing at Manal while we are conducting the Aman program. We as a human, you know, most of the people, they doesn't accept the changes, you know, and that change, it has to be driven by the top management. So from the top up to down, so the involvement from our top management, it was play a crucial role to set the mindset for all the employees. The regular, visible, felt leadership and the interaction with the shop floor levels, whether the contractors, the employees, and the initiatives to encourage those people to speak up, it's play a good role to change the mindset for all these employees. Plus, also the role model. It was showed the role model from the top management on the way how they strict on the safety rules and the regulation. I hope I answer your question, Manal.
Yes, thank you so much. Ahmed, you mentioned that 29% of the incident has the SEF potential, right? How did this insight change your risk prioritization and daily operation?
That's a great question. So what we did, Manal, actually, in the daily operation, as I mentioned in my previous slide, which is related to the SIF. Yeah. So what we did actually, on those 29th that we identified, which is a potential of serious injury and fatality. So each of these incidents, we set, for example, the control measures. We have to review again these control measures and to see whether we see ourselves, whether we control it better. Are we implementing these control measures up to the standard level or not? Plus, now for every activity or every critical activity, we have the checklist. So the people, they want to go inside in the site from the operation, including the safety expertise as well, and they start to implement the checklist on the critical activities, such as working at height, for example. And we set an additional control measures to ensure that the people who's performing these critical activities, they are well implementing, and before they implement, well, they adjust the control measure for them to implement it into the site.
All right, thank you, Ahmed. Ahmed, I have a question from the audience. Seeing that EMSTEEL are busy with Aman 2.0, when do you see EMSTEEL implementing Aman 3.0? So Aman 3.0 will start, as this is where the world, not just the steel industry, is moving to looking at the speed and effective of AI from day to day. Okay, so when do you see that Aman 3.0 will start, as this is where the world is, not just the steel industry, is moving to look at AI from day to day? So do you think that Aman 3.0 will utilize AI solutions? And how are you going to leverage from AI solutions?
Yes, actually, and we finalized, we already end from the Aman 2.0. Yeah. And the recognition was from the World Steel Association based on it. And we started already on the 3.0 Aman program. Yeah. So one of these initiatives that we have a smart what they call it system as an AI system, which is we launched it recently. That's mean now they like the system of the ChatGPT. So the people, whenever they have a question, sorry,
it's like a chatbot.
Exactly, it's a chatbot. That's one of the program that we already floated down now within the organization. So in case of some of the employees, they have any questions, okay, instead of calling the safety expertise or sending them an email and wasting a little bit time, so they can go through this the chatbot, and they can just ask the smart people how we're going to deal with, for example, permit to work, okay, how we will conduct the risk assessment, yeah, and which procedure could I utilize, for example, working at height, so this it will listed the answer of that employee and to give them the clear answer and where he can find even these procedures. Yeah.
Amazing.
So basically, Aman program 3, it is started. It is started. Sorry. And this time we have, and this time, inshallah, and we're going to start it by utilizing the resources who have the know-how from the beginning, from Aman 1.0 and Aman 2.0.
Amazing. Amazing. So you're going to utilize the knowledge in-house, yeah?
Yes, in-house.
Okay, I have one more question. Okay. May I ask the other audience to mute your devices, please? Okay. So you have mentioned a digital tool, since we're talking about digital solutions still, and based on the last question from the audience, you mentioned MOC dashboard and KPI tracking. So how do you ensure that digitalization actually improve decision making rather than just adding more complexity?
Basically the MOC we implemented once we implemented in Aman 1.0, it was basically manually, but now now we already making it digitalized, and this has helped all the relevant parties involved onto the management of change the steps of the digitalization, it's a very clear for all the parties. So he cannot finalize the management of change without, for example, the approval from or review from the health and safety department. So it will pass through the health and safety department for the review, and the health and safety, they will ensure that all these risks identified as being really identified, and is it clear or not? So the system will not move into the next step unless the previous step, it has to be finalized by the in charge stakeholder. So that's the good things within the digitalization of the such system. Otherwise, if it is manually, that's sometimes it's only a document work on the paper. So it can be passed, the health and safety, for example, by any of the stakeholders, and they can implement the change without even involve the health and safety, which is the most important parties at the end of the management of change. Unless there is an exception from the top management, from the leader, like a directors and above, to take the responsibility on some of the change, and they can bypass the health and safety. They have confidence, and they will take, because some of these MOCs, there is a lot of complaint that all these MOCs take a little bit time, so we don't want health and safety involved because there is not that much change. It is only basic things. Yeah. So that the management now, they start to take, for each department, they will take the responsibility so they can bypass this to goes to the health and safety. Yeah.
Okay. Bypass it with confidence, right? That it will not harm
Of course,
anyone.
bypass it with the
Yeah.
confidence. As we said, and now we have a great culture and system in place. And those
Mm-hmm.
people, they have a confidence to identify the risk by themselves. Yes.
Mm-hmm.
But I can say that most of the MOC, it is passed through the health and safety expertise to release it. Because the health and safety will go to the site with the end user, with the stakeholder who's on that area, and they will verify all the risks.
All right. But I have to thank you. If time's allowed, there will be, I will ask you one more question in the end from the audience. It came to you. But
Sure.
now we need to move to the next speaker. So allow me to share my screen. All right, perfect. So let's move to the next presentation. I have with me Dr. Paradeep. Dr. Paradeep, let me just introduce you quickly before you can start.
Good afternoon, everyone.
Okay.
Good morning.
All right. Just a minute, Dr. Paradeep, let me introduce you quickly. Okay. I don't know. Can you see my screen, everyone?
Not yet.
Okay. Never mind. So let me quickly just introduce you. So our next speaker is Dr. Pradeep Govindan, HSE team leader from Buruj. Dr. Pradeep Govindan is a senior HSE expert at Buruj, specializing in process safety and operational risk management. Today, he will be speaking on applying process safety fundamentals to steel operations. Dr. Pradeep, please go ahead and share your slides.
Thank you, Manal. Thank you for that introduction. Just give me a second. Let me pull up my presentation. Just let me know if you have, you're seeing my slide.
Yes, we can see it.
Okay. Thank you, Manal. Thanks for that introduction and also this opportunity to, be part of this excellent panel and this discussion. It's very interesting to see how the Aman 2 has emerged as a platform where you are creating visibility and discipline and follow through on safety performance. I want to shift the attention a bit away from the monitoring performance to actually what we are required to control in our operations. So I want to shift our focus to safety in processing energies that almost all the industries does. I mean, the term process safety is typically associated with oil and gas and petrochemical industry, but that's not true. Process safety is not industry specific. Any industry which is involved in processing materials, raw materials, manipulating it in one form or the other to produce something else at the end, they are very much a process industry. They are handling energy. They are processing energies in different forms. So you convert your raw material, you convert, you use electrical energies, chemical energies, thermal energies into one form to another form. So only the form changes or the kind of energy that you use in your process varies, but pretty much all of these are about handling extreme amount of energies, and process safety is all about controlling this energy. So the only real question is, what are these energies, where are these resided, and are we really controlling it, or we are losing control of it? So process safety stems from that aspect, whether we are controlling, whether we know where our energies are, and how we are containing it and keeping it controlled in a way that we want it to be used in our processes. So that's the fundamental theme of my presentation, though this 15 minutes is not good enough to go into detail, but I have chosen process safety fundamentals and some tools associated with to anchor this discussion. So if we know that energies are what we need to really manage or really control, we need to know what are these energies, or where do they manifest in our operations, and what could happen if they go out of control. I mean, I something, the SIF, or basically it's the high consequence, low probability event that we are talking about. When process safety also, we are trying to manage all those events which have got very high significant consequence, though it does not happen on a more frequent basis. So we are shifting our attention from high frequency, low consequence event to low frequency or low probability, high consequence events. Yeah. And for that, first we need to know what are our high consequence events. What are these major accident hazard that we have in our industry? Now again, MAH is a term used in oil and gas industry. Well, you could associate that with the SIF, so anything that has got serious injury and fatality potential. So what we are really dealing with here is what we, I mean, the MAH is nothing but controlling energy, controlling high consequence event that occur when we have lost control over our energy. So in other way, if we can say MAH is equal to loss of control of energy. So if you see here, I just tried to map, give some example of what an MAH would look like in oil and gas industry, as well as what would it be in steel, steel manufacturing industry. In oil and gas, the primary focus is about handling huge inventory of hydrocarbons under pressure. So the hazards are mainly about losing control of this hydrocarbon, escaping from their primary containment, and that could lead to different types of vapor cloud explosions or fires or toxic releases. Now, when we look at steel, well, we may not be processing hydrocarbons, or rather, hydrocarbon is not your primary raw material or inventory to produce steel, but we are still managing or still handling extreme energy systems. Like you have thermal energies. Well, you know what a molten metal can do. Extreme heat. Chemical energies. Your furnaces, they produce toxic gases, flammable gases. The hazards associated with carbon monoxide, etc. You have high pressurized systems, your steam systems, or utility system, which can also impact and create major injuries or serious injuries and fatalities. And the water metal interaction, imagine water falling onto a molten metal of 1600 degrees Celsius, a steam explosion, and all these hazards. If we lose control over these energies, then we would see the run out risk or molten metal breakout issues, steam explosions, gas explosions, or now oxygen related fires. So it's a different hazards in different industries, but the same physics of loss of control or physics of containment is applicable. So that is why whether we are managing hydrocarbons or molten metal, the objective is exactly the same: to control these energies, to maintain the containment, to maintain barriers and defenses, to prevent the consequences. And that is where the concept of process safety fundamentals, or the operational condition which needs to be present always, all the time, for this escape of energy does not happen. So the process safety fundamentals are coming into picture based on this particular requirement or a need or operational condition that energy must be always controlled. Now, this is not come out of some research report or research review. It's actually a cross-consultative team from international oil and gas producers. They had studied around 10 years of major process safety disasters. Around 56 events were mapped, around 128 fatalities for a period of 10 years. And they came up with these 10 fundamental operational conditions which are mandatory to be available all the time. Yeah, it's not about something that is on book, something's in back of your mind, but it's a condition that must be existing every day, round the clock, when the operations are going on. So right now, when we are sitting in the webinar, we have our plans running, and these 10 conditions must continue to operate, continue to function. Yeah, so that it's important to understand that these are not some sort of behavioral checklist or some intentions or some slogans. They're basically conditions that must be true always, all the time when our operations are going on. So instead of asking, are we following procedures, or the process safety basically asks, currently, do you have safe isolations in your plant? Do you have barriers which are working? Are you controlling your ignition sources? Are you working within operating limits? Yeah. So that's a background of process safety fundamentals. Now, once we understand the process safety fundamentals, then we also need some tools to make sure that these fundamentals are correctly mapped, identified, and they are effective. So it's not just having these in place as a bureaucratic activity, but it's really whether it's really working. Are they really effective? So we need some tools to demonstrate its effectiveness and evidence that it is really helping, it is really protecting your, really helping you contain all the energies. So I will not be able to go through all the 10. I've selected a few which is very much relevant, and some of them you have already probably have processes in place to manage. So let's start with the first fundamental. And anyway, there's no first, second, there's no hierarchy to follow. All the 10 fundamentals are equally important. It carries its own weight. But I start with this one, which is respecting hazards. Now here, I mean, the wording here is very deliberate. We're not saying we identify hazards or we should know the hazards. We're saying that we respect hazards. Yeah, because when you respect something, you are constantly aware of it. You're constantly mindful of its presence. You don't take it for granted. You don't fool around that, or you don't become too comfortable around it. And that is exactly the challenge in most of the operations. So many of our activities, when you see every day you're interacting with it, your mind, there's a mind adjusts to it. The mind normalizes it, because that's how your mind adapts for you to be more productive. So this thing will create risk normalization, as they call in behavioral safety, and this risk normalization can lead to complacency and people ignoring the presence of hazards, or it creates some sort of desensitization to these hazards. So when we respect hazards, we respect its presence, we respect its boundaries. So all those exclusion zones that you draw, all those visual communication that you establish, your posters, your warning signs, your floor markings, all these are basically letting you know that there is a hazard, there's an energy that you need to be mindful about, keep yourself away from it. So it's not just a kind of layout marking. It has come with this particular need or requirement that you completely be aware, always be aware of these high energy hazards around you. So before, not just knowing, but before you start any task, you must ask that question. So what happens if control of this hazard is lost, or control of this energy is lost? Because once you truly respect hazards, you don't rely only on human awareness. You need some tools to really quantify them, measure them, monitor them. So that's why you do all sorts of hazard identification studies, whether it is HSCIA or HAZIT or HATE, NVIT, or there are a number of tools that you basically do, basically to make sure that you map every significant high potential hazards or energies, and then you go ahead with the area classification. You create the exclusion zoning, you put the visual controls and markings. So these tools are helping us to ensure that the hazards remain visible. People are being told about it. We don't rely on people's memory. Yeah. So once we understand and respect these hazards, the next question is, how do we control them? So what are the control that is available, or how do you make sure that you have enough defenses around those high energy hazards? That's where a tool that is commonly used in process safety or oil and gas industry called layer of protection analysis. Well, it can be qualitatively used, it can be semi-quantitatively used, it could be quantitatively used. But normally, as part of quantitative risk assessments, to establish the risk reduction level, they use some mathematical probability figures to decide whether you have enough layers of protection around this hazard to reduce the risk to a reasonable level. So at simplest, LOPA is asking just one question: do we have enough independent defenses or independent layers of protection around our hazard? So basically, multiple independent safety nets. One fails, the other will kick in. If that fails, the next will kick in. So starting from the basic process design, yeah? I mean, here I just give an example of furnace wall thickness. Then you have the basic process control system, which is basically adjusting the temperature and all the operating parameters. Yeah, if something exceeds, then you have alarms where the operator is intervening. And if that also fails and it further reaches the safety margin or safety limit, then your safety instrumented system will kick in, your interlocks will kick in. Yeah, if that also somehow fails, then your containment measures, your physical protection, your passive means of shielding, bunding, and then your emergency evacuations will. So these layers will tell you which are safety critical, which requires more integrity measures. So each of these is a barrier, but the most important factor is these barriers must be independent. If one fails, the other must kick in. There must be enough redundancy. Yeah. So it calculates in a quantifying respect. It calculates whether we have enough protection for the frequency of the initiating event. So it's basically asking the question whether we have enough layers to lower the probability of failure on demand. So when we need them, is it lowering the probability of failing? So instead of assuming we are safe, the LOPA is forcing us to prove through multiple layers that we have sufficient barriers, yeah, to prevent a top event or prevent a loss of control of energy. Now, once we define these barriers, the next challenge is even more critical. How do we ensure that these barriers are, they remain effective? It's not just about having these barriers in place, but whether it is reliable, whether it is effective. So having a barrier on a paper does not mean that it's effectively safe. That's where the next fundamental comes. We sustain barriers. So we continue to make sure that these barriers are available, accessible, reliable. So a barrier can be any control that prevents an unwanted event or stop escalating into a major loss event. So if you see here an example in a furnace system, you can see multiple types of barriers. You have the passive hardware barrier, which is your refractory linings. Yeah. Then you have the active system like your water leak detection. Then you have the human barrier, which is basically the operator's intervention and verifications. So these barriers are what is keeping your molten metal contained within the system. But the key point is a barrier is only effective if it is functioning right now. It's not about when you do your inspection, it is working, but is it working continuously around the clock when your process is going on? So any degradation in your barrier means a failed barrier. So for example, if your refractory lining is your primary containment barrier, if that thins beyond certain tolerance limit, then it is not degrading or downgrading, it is failed already. So it's not about readjusting or you reduce your inventory or reduce your operational load. It's about it's already failed. It's just a matter of time that it can get converted into a major run out case or molten metal splash issues. And that is how incidents happen, not because barriers don't exist, but because they are assumed to be working when they are not actually working. So having a barrier is not enough. Sustaining the barrier is more important. It's about having systems to monitor, to inspect, to verify continuously. Yeah, because what LOPA defines as protection, this fundamental will ensure that that protection is remaining real. And to manage this effectively, we need to have a structured way of visualizing all the barriers that we have, all the barriers that we have to prevent a top event, and also the barriers to mitigate an event. And that's where the bow tie concepts or bow tie tool comes into picture. Now, this may not look like a bow tie. Bow tie essentially, if once you build the barrier diagram, it will ultimately look like a bow tie. You will have a center knot here, and then you have the preventive and mitigative barriers on left and right side. So it's basically mapping the cause and consequences. So any top event which is from your major accident hazard which you want to control, if somehow you lose control, then you may have a lost top event. And this loss of control happens because of certain threats, certain causes, which will be mapped on your left side. Say, for example, I've taken the example of cooling failure. If cooling failure happens, then this top event could manifest. And what happens if this is not controlled? It could be, explosion or a fatality. So you put barriers in between the threat and the top event and the consequences. And these are the barriers which needs to be correctly identified and mapped. These barriers by itself are not 100% foolproof. So this may have its own weaknesses. I mean, I'm sure you're familiar with the Swiss cheese concept, the Swiss cheese, the Rasmussen's theory, where each slice of cheese has got certain weaknesses, certain drawbacks. So those are called as escalation factors of your barriers. What could make this barrier fail? And that kind of understanding is required so that you put a control for those escalation causes. So that's how this bow tie will connect the threats, or rather the causes, the barriers, the top event, the consequences. So from preventive barriers on the left side to mitigative or the or protective barriers. Now this bow tie analysis will map the entire barriers that you have, and from there you can keep monitoring them. Now once you identify the barrier, definitely the next step is to make sure that you monitor its performance. Yeah.
Dr. Pradeep, okay. Yeah.
Yeah.
Yes, Doctor, thank you so much. I have a question for you. Okay. So, Doctor, you emphasized that process safety is about controlling hazardous energy. How can steel companies practically shift their mindset from traditional safety to this energy-based thinking?
Can you repeat that question, Manal, again? Sorry.
So how can steel companies shift their mindset, since you mentioned controlling hazardous energy? How can steel companies practically shift their mindset from traditional safety to this energy-based thinking?
I think your question itself has the answer. That's actually a good question. You talk about mindset, right? It's basically changing your mindset. So instead of setting your mind to what you're currently doing, you just need to unsettle it and shift towards the high consequence, low probability events, so where your SIF potentials are residing. What we are basically talking about is all those conditions, all those energy or systems that has got serious injury and fatality potentials. So most organizations are already doing a lot to control this, but sometimes the focus tend to shift to those high frequencies, something that you see every day: sleep, trips, falls, bumping into structures, not wearing PPs. So I'm not saying these are not important, but they may not define the business sustainability or business continuity. Those are important, but they don't reflect what can actually lead to an SIF. So the shift begins, I think, with the leadership, where it's about how they position themselves in their daily conversations. It depends upon what leaders talk about every day. If the conversation is always about TRIR or the injuries or PPEs, then the focus is not in the right place. If leaders start asking what are our major accident scenarios, or if employees are able to identify their SIF potential areas, what are hazardous energies they are encountering on a daily basis, what are the barriers that they have to control them, then the organization start shifting their mindset or started thinking differently. So this is not an overnight solution. You need to have this conversation over and over again. Keep focusing on your major accident hazards. Keep focusing on SIF. Yeah. So, I mean, you need to make that visible. Practically, the shift is to make these energies or the potential of these energies more visible through engagements, through conversations, adding that into all training programs. Talk about consequences, not just about incidents or what happens. Talk about what consequences are the major defining your safety performance, and also the barriers and the not just having a barrier, but the integrity of the barriers, not just behaviors, not just focusing on changing our behaviors, but human fallibility is we cannot completely avoid, but the barriers which are independent of people, those are the ones which you need to focus on. If you talk more about it, I think the mind will shift. So mainly mindset can be changed by talking more about something else that is of more importance to you. Sometimes you may just ask a simple question to people, whether people know what the major accident scenarios are, what the SIF potential SIF situations are. If they do, then the mind is already shifted. If they still talk about PPEs or sleep strips and falls, then mindset has not shifted to energy-based thinking. So we are talking about a significant amount of energy that can really impact your business, right? So we don't shift the mindset by just training. We shift it by changing what we talk about every day.
Since you mentioned leadership, I have the last question for you, and I want you shortly to answer me what are some of the practical ways leaders can encourage reporting of small anomalies, before they escalate?
That's a good question, and that's a challenge all industries have, not just steel industry. Reporting, it's less about process and more about human behavior. And even now, after so many years of experience in the safety field, we tend to hesitate to report because there has been no action around it. There's no feedback. So people don't hesitate to report because they don't understand the risk. They hesitate because of either fear, or the process is too complicated for them, or they've been doing all their life but they've not been getting any feedback or any follow-ups. So what leadership should first do is to create a kind of confidence or comfort in reporting. People should feel safe and people should feel confident that their report will not go against them, or their report will be acted on, or they will be given the feedback on it. And close the feedback. I believe if you start feeding back whether you took action or not, it helps, it encourages people to report. And third, I think you need to connect their reporting to the impact also. You need to tell them how their observations or how their reports have really helped in improving the process, improving the condition, how they have helped in preventing a major injury to a colleague, or impact to the business. So if people don't feel safe reporting small things, they will they will be forced to report only when something major happens. So let them feel comfortable reporting any minor things, and leaders should encourage and support that.
Perfect.
Yeah.
Thank you so much, Doctor. Yeah, thank you so much, Doctor. We have now the second speaker with us, Mr. Stephen Strauss. Can I ask you to share your slides? So we have now Stephen Strauss. He's the HSE director at Algerian Qatari Steel. Stephen brings extensive international experience in safety and risk management, translating insights into practical, action-oriented strategies across operations. Today, he will present on turning safety insights into action. Stephen, over to you. Okay, we can see your slides.
Good afternoon. Good afternoon and welcome everyone from the MENA region. Thank you for joining the webinar, and let's turn the safety insight into action. So I'm going to try to keep mine short and brief because I know everyone it's already been a long day for everyone. So just bear with me If the audio sounds weird, keep in mind where I am now, it's starting to rain heavily. So if there's anything, just let me know. That being said, safety, we're sitting with the safety data challenge. So I think most companies, everyone, we sit and we collect a large volumes of safety data. We have got incidents, we've got inspections, we've got audits, we've got observations. And the key thing here is, do we really review everything together and we combine everything so we can actually have a proactive decision? The key takeaway here is we have many safety systems, but they always remain reactive. And we need to focus and move that to proactive. So currently, as you know, traditional models for anything that happens is we've got an incident, we've got an investigation, corrective action, and then we close it out. So we focus on finding those, we need to focus on finding those patterns, and then we can use that to do early prevention. So if you look at this, we collect data, we analyze, and we generate insight. So think of our process as a funnel. So we collect, we analyze it, we interpret it, the insights, and then our insights proceed and into effective actions. So if we look at our normal safety intelligence model, we have data, we analyze it, and the key point here is the insight, then the knowledge, action, and then active safety. So, I mean, for anyone that's asking the question insight, it's usually you've got data, but you have to take data and you have to change it into knowledge, and that takes insight. So it's a common thing that a lot of us are missing in the industry because we're bombarded with so many data and everything in front of us. But if you just pay a little bit more attention into the details, you can quickly get insight, and you can use that insight to actually move into the predictive side of safety, into the predictive realm that we all want to be. We don't want to focus on leading. We want to be. We don't want to go in the lagging. We want to be in the leading indicators. Sorry, Mike. So a case study at AQS, we use integrated data revealed across cross-functional risk drivers. So I'm going to share with you quickly. This is just last year. As you can see on the graph on the left or right-hand side, that's our major, or not major, but most of our insights that incidents that we had. And let's pause a second. So you can see the key one is at the bottom. It's slip, trips, and falls. And that accounts to about 43% if you calculate everything. That's what was causing most of our incidents that we had last year. So based on that, we went into behavioral improvement, we went into accountability, routine, daily routines, shift-based cleaning programs, and then we introduced the 5S cleaning method and also our stop program. So just for everyone, we're going to just show you quickly our 5S model. It's not something new. It's not something that we designed from AQS side. This is a very old process that was started by Toyota years back. And the main thing for this is the operation benefit is to measure standards and then drive consistently into housekeeping. So you can see the 5 S's. It's set about, set, sort, everything is there. So here's an example of what you can see. We're scoring the transformation into measurable fields, and then we can use this as performance indicators and we can measure this. I was trying to explain that currently we've got a table like this. We also have a digital version that's in the works, and this has been done on a monthly basis. People go, they scan, and they fill this out. So as you guys can see, the 5S cleaning method, it's like I mentioned, Toyota started it. It's not something new. The first one is you sort. Second one is set in order. 3 is shine. 4 is standardize, and then the fifth one is sustain. So it's in the bottom. You can see everything there. And what we've done is we've created a checklist out of each one has got. It's actually in the next slide. So you can see separately we've got a section of questions for each one. 4 questions each. Each one counts 5 marks, and this is done on a monthly basis. Everyone takes this. We usually have 3 people. Our environmental head of the department will go through it. One of the section heads for the specific area, and then another one of our safety supervisors will go through it. All 3 will fill this in. It's unbiased. You just go for a specific area, you give it a mark, and at the end, you will get a mark out of 100. And the 100 is usually then you get your benchmark out of that. And then from there, you can use it to see where your biggest areas are, and then you can directly use that information with our stop card system, and then you can actually proactively sort out the issue before it happens. So we had a reduction from 43% with slip trips and falls to about we've had for the last year maybe 2 slip trips and falls, and it's not even in the same area where we picked up most of it, where we implemented this as our pilot session. So we currently have great success with this. So moving forward toward proactive safety, we want to proactively require data as an early warning system and then act on it. Because I mean, it's the early signal for everyone. But that being said, the key takeaway from this is insights must lead to targeted, owned, and time-bound actions, and it must be measurable. So if I end this off, quite frankly, to close it, you've got data, you need insight, and then you have action. So proactive safety is achievable through early intervention and measurable follow-through.
Stephen, I appreciate your informative presentation. I have a few questions. So you presented the journey from data to insight to action. What is typically the biggest gap organizations face in moving from analysis to real action?
That's a good question, Manal. So what we find is the biggest gap usually with this is this clear ownership and follow-through. To fix this, you should assign actions to a specific person, not a department. Set clear deadlines, to follow closure, and then check completion in the field, not just on paper. Otherwise, it's just a tick box. And a simple rule: if no one owns it and checks it, it won't happen.
Okay. The 5S scoring system is simple yet effective. How do you ensure that it remains a meaningful safety tool rather than just a checklist exercise?
So the 5S system, it should focus on risks, not just the score. To make this meaningful, you should always ask yourself, what risk would we remove during this during the 5S audit or checklist? You can call it whatever you want to. You should involve operators, identifying issues. You should fix problems immediately where possible, and use scores only to trigger actions, not to impress anyone. That's not the idea of this. Is to see where the biggest issues is, and then if it doesn't reduce risks, it's just paperwork.
All right. Okay. My last question for you, and I encourage also audience to put their questions in the Q&A chat box. In your experience, how can companies use safety data to become truly proactive rather than reactive?
So this, I would say, you should always focus on warning signs, not just incidents, because incidents had already happened. To do this, track your near misses, your unsafe act, your unsafe conditions daily. That's why we've got a stop program that people can access through their phones. If they see any unsafe conditions, they can actually take their phone, they can scan the QR code, and then they can fill in any unsafe act or conditions, and we get the information directly. And then we should look for repeated issues and analyze them. A good practice from what we've seen as well is to either hire or take one of your current safety employees that you have and focus on behavioral-based safety. So get someone that's focused on behavioral safety, and then they will basically, you assign them to dissect each and every near miss, unsafe act, incident, everything, and look for the commonalities between everything. Find what's hidden. Is it behavior? Is it unsafe act? Is it unsafe condition? Is it age thing? There's so many value that you can have with if you have a dedicated person that goes through everything and analyzes everything. And that touches into what the first presenter said, where we start moving into the future with AI, with predictive analytics. It's the same principle. That's something we strive to from our side that we want to bring into AQS as well, is using the information that we already have, already gathering it, and then taking it from there and bringing it into a model that can predict rather than us running after the problems. So that's one thing, and then act at a supervisor level. Discuss the trends that you pick up on daily toolbox talks. Fix the small problems before they become the big incidents. That's hopefully that answers it.
Yes. Thank you, Stephen. Now, okay, our final speaker is Khaled Mohamed. Khaled is an industrial safety manager from EMSTEEL. Khaled Mohamed is an he's a industrial safety professional specializing in steel manufacturing hazards, safety systems, and DRP operations. He supports EMSTEEL safety frameworks through risk identification, hazard mitigation, and strengthening operation reliability. Today, he will discuss safety in direct reduction plans. Khaled, please proceed. Please proceed.
Thank you, Manal, for your introduction. Good afternoon, everybody. Today, I'll be presenting about safety in direct reduction plants with a focus on madrasa technology and practices applied in our plants. During the presentation, I will start with a brief introduction about EMSTEEL. Then I will go through the main safety systems used in our plants. After that, I will highlight the main hazards in the steel industry, followed by a focus on process safety philosophy. And finally, I will discuss safety and process safety. I will discuss personal safety and some incident statistics. EMSTEEL is one of the leading steel producers in the region, with multiple plants located in Alexandria, Suez, Sadat City, and Thames of Ramadan. These plants have a combined production of a total 7 million tons per year, which makes safety management a critical priority across all sites. I will go through some examples on our safety systems, and I will start with permit to work system, which is very important system that helps to control hazards inside our workplaces. EMSTEEL categorizes the system into standard permit to work system and confined permit to work system. The permit to work system issued for non-routine high-risk activities like maintenance, repair activities, or any other activities that pose high risk and may cause harm to workers. Toolbox talk also is issued and attached to the permit to work system and signed by all workers who are contributed to the high-risk activities. And these our forms that used for permit to work system, the standard permit to work system and confined space work permit to work system, which is include the measurement of gases inside the confined space, in addition to the heat stress or any additional physical hazards that may exist. Tag-out system is also used for isolation of equipment before any repair or maintenance activity to ensure that the equipment is de-energized. Also, EMSTEEL is looking forward to introduce lockout system, but not yet, because some modification is needed in the electrical panels to be suitable to the lock system. Near-miss, also our near-miss system is one of the systems, as you all know, that could help to prevent the harmful event before it happened. And also it enhances safety in the workplace and promote positive safety culture. So we initiated an electronic system to record the unsafe acts and unsafe conditions in our workplace. Also, all employees can record the near miss and submit it in the electronic system. Corrective actions are taken and to prevent the recurrence of near miss and absolutely prevent the harmful event before it happened. We recorded about 9,000 near misses during the year 2025. Risk assessment also is carried out inside the steel through higher process, which includes hazard identification and followed by risk assessment and risk control. Hazard identification is carried out for all processes inside our plants. Risk level is then determined through the multiplication of severity and likelihood. Severity are categorized into 10 categories and likelihood also the same. The result of the risk level can determine whether it's low, medium, or high. The low risk level does not need further action, while medium and high risk need further controls to reduce the risk level. A lot of training programs are implemented inside EMSTEEL. Training and education, as you all know, helps keeping everyone informed about the safety practices and latest regulations. Also, it helps promote positive safety culture. So we are implementing a lot of safety programs like newcomer safety training. We are also implementing some specialized safety training like OSHA, like scaffold erectors, like scaffold inspection programs, and other safety training. Effective communication is one of the tools that helps build trust and ensure that problems are addressed promptly. Some communication tools are inside with the DK, like Central Safety Committee, monthly meetings with supervisory levels, contractor safety officers, toolbox talks, a lot of meetings regarding safety, which is enhance the leadership and promote positive safety culture, which is the most challenging target in health and safety nowadays. Emergency drills are implemented according to the annual plan. And here you can see an actual drill which held in one of our plants. These drills are being implemented according to the plan. The emergency drill could be implemented to make the emergency team aware of the workplace and weaknesses of the drills are addressed, and to make the emergency team to be ready in case of the actual situation. Steel industry is one of the high risky environment due to a lot of hazards involved. Asphyxiation is one of the most critical in the industry, especially in direct reduction plants. Moving machinery strongly involved in rolling mill plants, while physical hazards like heat stress, noise are mainly in steel making plants, and entanglement and traffic hazards strongly exist in the shipping yard where trailers and cranes exist. I will go deeply now through the direct reduction plants and MEDEX technology, as EZDK direct reduction plant is operated by MEDEX technology. Simply, the process of direct reduction plants in MEDEX technology, if we start with the gas exits the shaft furnace through the top gas duct, it goes through the top gas scrubber for cleaning and cooling. The gas then passes through the process gas compressor to increase its pressure, and then to the heat recuperator for heat exchange. Finally, enters the reformer for reducing gases, which is mainly hydrogen and carbon monoxide, and then to the shaft furnace for the reduction process. The main concept of MEDEX process is safety philosophy is never allow air to enter the reducing gas loop or shaft furnace. We can enforce this concept by keeping system pressure always positive inside the shaft furnace, and we will guarantee this through operating the system pressure of the shaft furnace with 0.4 bar above the atmospheric pressure, and also sealing the top and the bottom of the shaft furnace with sealing gases with a pressure of 2 bars, and finally interlocks applies to mechanically close the shaft furnace in case of something wrong happen. Also purging may occur. Oxygen monitoring is early warning system. Medrex relies heavily on oxygen analyzers. As a result, all gas streams are supplied with these analyzers, and this is one of the graphs that shows the oxygen concentration in a specific area and time. If something goes wrong, speed matters. So automatic purging for all gas loops using purge gas, which is mainly nitrogen and carbon dioxide, with 14 bars pressure to eliminate any combustible in the pipelines. During startup and shutdown in direct reduction plants, some safety procedures must be applied, as Medrex startups without proper purge may cause explosion in a few minutes. So during startups, gas leak test for all pipes that was under repair or dismantle. This is the first concept. This is the first step, sorry. The second one is reformer air purge. The third one is to verify zero combustible gases using the analyzer. And the last one is maintain standard system pressure before introducing reducing. During shutdown procedure, gradual replacement of reducing gas with nitrogen and maintain pressure until oxygen is proven. When air ingress is suspected, no troubleshooting while gas is live. The logic of emergency response must be as follows. The first is to trip the reducing gas inside the loop. The second is to inject nitrogen. The third step is to isolate affected area and to maintain a positive pressure inside the shaft furnace. And before restart, oxygen concentration must be verified using the analyzers. Four golden rules for the operators. Pressure protects you, which means the pressure inside the closed loop and shaft furnace is mandatory to protect the plant from a trip or fire or any catastrophic event that may happen. Nitrogen buys you time, which is mean ready nitrogen buys you time as it helps to prevent the harmful event consequences. The harmful consequences like fire, it's suppress the fire and prevent any further consequences that may happen. Oxygen analyzer must be maintained so it will tell you the truth about the oxygen concentration inside the closed loop. And finally, trips tell you that something goes wrong before the harmful event happens. So they are friends, not enemies. During storage of direct reduced pellets, the risk of pellet reoxidation involved, as the oxidation is an exothermic reaction which is emit heat and may cause fire. So some procedures must be applied, like storage under sealing gases and monitoring the composition of and the pressure of these gases. Storage of pellets outside. Some other precautions must be applied, like storage for only aged product. The pile must not exceed 1.5 meters and always monitor the temperature of the pile and avoid storage in rainy season. Asphyxiation is one of the most critical hazards in the steel in the direct reduction plants. The asphyxiation by carbon monoxide, which is the silent killer, as it's colorless, odorless gas that may cause adverse effects to human who inhale this gas, causing dizziness, nausea, and may reach to death in case of inhalation concentration exceeding the lethal. Its symptoms, as we said, dizziness, chest pain, confusion, blurred vision, headache, shortness of breath, and nausea. So, carbon monoxide fixed gas detectors exist in places where accidental release of carbon monoxide is suspected. The reading of these detectors are displayed in the monitors for the desk operators and also for the field staff in order to take action in case of any accidental release. Moving machinery also involved in the direct reduction plants during, especially during the process of inspection and cleaning. So we are allowing only competent person to access the vicinity of moving conveyor, also to stop the conveyor in case of interpretation with the moving rollers, and periodical inspection for the pull codes. A lot of confined space in the direct reduction plants, so the precautions needed for confined spaces access are taken. People who are existing in the shaft furnace are using the portable respirators, which consists of purifier and regulator and full face mask, which is directly connected to the plant air line and guarantee a continuous pure air supply. In the blower area, the same hazard asphyxiation. We are installing digital detectors in place with alarm and sirens. In the reformer area, the same hazards, except in dust inhalation during the replacement of catalyst. Safety initiatives during the last years, we initiated an electronic system for recording all incidents for the ease of data retrieving and statistical analysis that could help further to take proper actions. Also, contractor fitness training campaigns are being implemented for improving the physical and mental health of contractor workers. Monthly meeting with all supervisory levels and contractor safety officers to communicate the recent safety regulations and serious safety occurs during the month. Periodical auditing on the contractor warehouses to ensure that all tools in good condition. As the steel was recognized by all the Steel Association for implementing a new system for newcomers training during in the year 2018, the system aimed to ensure that the newcomer will not be involved in high-risk activities except after receiving a proper classroom training and on-site training, which helped actually to eliminate the injuries of newcomers. And finally, this is the lost time injury frequency rate during the last 10 years, which is has a decline trend line flickering around the wall steel average and hopefully to reach to zero lost time injury frequency rate in the near future. Thank you.
Thank you, Khaled. Thank you for the presentation. It's very good. Khaled, I have a few questions for you. You highlighted that Mederick's operations pressure protects you and oxygen tells the truth. So how do you ensure strict discipline around these critical parameters during operations?
Okay. As you said, Manal, oxygen and pressure are the most critical parameters in Mederick's plants. So oxygen analyzers installed in all streams while periodically maintained with interlock system to trip the plant in case of exceeding the permissible limits. In addition to the pressure, also installation of reliable pressure sensor integrated with the control system, also with alarm and interlock system to trip the plant. Using control valves and also and regulations is mandatory with routine inspection on these valves. All these parameters also are monitored for the desk operators, and they are seeing what happened inside the cluster.
All right. Okay. I have a question from the audience in here to you, Khaled. Okay. So, Khaled, you mentioned that approximately 9,000 near misses were reported in 2025. Could you share the key strategies you implemented to achieve such a high level of reporting? Specifically, how do you effectively motivate employees to report near misses while managing the administrative burden typically associated with such a large volume of reports?
Okay. Near miss system, as I said, all employees have access on the electronic system. So all employees can do it electronically from their mobile phones. We have a parameter in the appraisal system of each employee. If he recorded, for example, 50 near misses, he will take 10 out of them. If he got only 40, so he will take 8.
So you have set it as a KPI.
Sorry?
So you have set it as a KPI. You have set it as a KPI part of the performance management. Okay.
Yes, the KPI for all employees. So, and also we categorize these near misses from low, medium, and the highest. Because of considering near misses as one of the KPIs, drive employees to record anything you see in the plan. So they might record something which is low severity. So we are categorizing all the near misses from low, medium, and high in order to be categorized for.
All right. Okay. One more question to you, Khaled. Many incidents occur during startup and shutdown. What are the key controls that organizations often underestimate during these phases?
There is a work standard for startup and shutdown procedure. The work standards, written standards. So supervisory levels who are involved in this process of startup and shutdowns must obey this standard. This is the outlines of the standard. Detailed standards are written, so they must follow it as it is. For example, if the temperature of the process gas reach to 70, you must go to the next step to open this valve. After that, you will go to open the second valve. After that, you will relieve the pressure. If the temperature exceeding something, you understand? So a deep, detailed instructions are written and communicated with all supervisory levels who are involved in this process.
I think I'm looking at the time and it still allows us to ask you one more question, Khaled. Okay. So you mentioned that the root cause is often just this once, okay, behavior. How do you effectively address this mindset on the shop floor?
It's about communication and leadership. Training and leadership. The effective communication between the shop floor level and management team promote positive health, positive safety culture, which is definitely, change the mindset of workers to safety. We are looking all safety practitioners to change the mindset of workers towards safety, even in absence of the supervision. That's challenging.
Got it. Thank you, Khaled. Thank you so much for your informative presentation. I still have a few questions for other speakers. So there's a question from the audience to Ahmed. Ahmed Al-Jadidi, are you still with us?
Yes,
Ahmed?
Manal. Yes.
Okay. Ahmed, what kind of recognition is given to employees that demonstrate commitment with safety? So how do you encourage our employees at EMSTEEL, to commit to safety and to comply
See,
with the safety
uh,
standards?
that's a great question. Actually, we have the what they call it, the procedures, which is already signed off by the management, and it is managed by the HR. So in that procedure, we have the best HSE employee of the department on a monthly basis. And we have also the best of the HSE section as a whole section in the department in a quarterly basis. So they will, the management will appreciate and they will recognize the section as well, not only the employee during the month, during the HSE monthly meeting. And we have also the best of the HSE employee of the year. Yeah. And best of the HSE department operation of the year. Yeah. So the final also, we should not forget, it's not a recognition for the employees. It is also included the contractor. So we have the HSE best HSE contractor of the year as well. Yeah.
Okay.
So all those categories, it is end up belonging to that procedure for the rewarding and recognition. Yep.
Okay, very good. Amazing. All right. Paradeep, are you with us?
Yes, Manal.
Yes.
Can you hear me?
Yes, Dr. Paradeep, I remember before I left Buruj, we used to take 2. Do we still take 2 at Buruj?
Yeah, we do take 2, but we call it a different terminology now. Yeah. It's dynamic risk assessment. Basically, you're stepping back, spending 2 minutes and assessing the situation or do a risk analysis within your mind and then proceed. So take 2, the slog is no more there. So, but yeah, the way concept is still going on.
Okay. All right.
Some companies call take 5. So it all depends. It's basically fundamentally asking you to stop, step back, take 2 minutes or 5 minutes, assess the situation, know what you need to do, have your controls in place, and then proceed. It's a lovely thing which needs to continue actually.
Yes. Dr. Pradeep, the concept of barrier, health, and degradation is very powerful. So do you ensure that organization, or how do you ensure that organization do not normalize degraded barriers like weeping pipes or bypassed interlocks?
Yeah, that's actually a real problem, and we know that majority of those accidents don't happen because barriers were missing, but it is mainly because barriers are not reliable, or barriers were there but it was bypassed or taken off. So one thing that Buruj or ADNO group of companies does is they have a process to classify all these downgraded situation or degraded barriers and treat that as downgraded situation. The moment we don't have a particular barrier in place or it's been taken off or bypassed for some maintenance, some activity, then that situation gets entered or that asset or that equipment gets entered in this DGS process where there is a risk assessment that is being done, and then you do some kind of mitigative measure to cover this app situation, and that is continuously monitored. So if it requires an extension of that period, then there is another escalation happens to the leadership. And if there are something that is in a downgraded condition or degraded situation for more than 1 year, then that gets entered into the enterprise risk management register, and that is gets tracked at the CEO level. So there are different escalations happen. The moment you identify that something is being taken off, something is degraded, then it is classified as downgraded situations, and then a different process kicks in. So practically, what helps is first we clearly identify what our these critical safety barriers are, which are non-negotiable, which needs to be working all the time. Secondly, treat any of these degraded situation in a separate category. Create an inventory of this downgraded situation, not just another work order or work order in a backlog, but have a formal process for what we call as downgraded situation risk assessments. So the real failure is not the degradation. It is meant to happen when you have old equipment which is continuously being operated close to its the operating limit. The failure is when we don't identify them, or when we stop seeing them and seeing them and not taking action on them. So the risk is not the barriers that degrade, but the risk is on that we learn to be too comfortable with it, or we learn to live with it. That is the problem.
Okay.
Yeah.
Thank you, Dr. Pradeep. Stephen, I have a question for you. You have asked Ahmed about the digital tools in place. So I have the same question to you. What role do digital tools and data analytics plays in enhancing real-time safety monitoring and decision-making?
Okay, that's a good question. So I think everyone is now, looking at all the different tools on the market. There's so many. I mean, you can just open any social media page and you will be flooded by all the different sources that's available. So we in the market, we're looking for, seeing that our whole plant is under surveillance cameras, not just from a disciplinary perspective, but from a security perspective, from our intervention perspective, we need to be able to see everything. So one of the main things we're looking at this year is getting AI monitoring systems for our security department, seeing that they can, you get so many different new ones. You get AI cameras, but you can also get existing software that works with the cameras that's already available in your facilities. And then the nice function about those are they can actually do the work of, if you've got, let's say, 300 cameras around your complex, you need multiple people monitoring that on a daily basis, and you will miss, the slightest thing and you'll miss it. Whereas AI can now be programmed to actually look at everything, from a person not wearing PPE to someone bending in a wrong position, to getting close proximity into forklifts. So for us, it's to get that perspective of, I know AI is, everyone is talking AI, and it's not going away. For us, we need to start implementing AI as far as we can as a tool to, not to take away jobs from people, but as a tool to enhance our safety and to use that as predictive analytics as well. So, and we're also looking into models of AI. Like I mentioned in the presentation, is we have so many data, and you have to physically go through it. Someone has to go through it. And the nice thing is, if you have a decent AI model, all of this information can be put inside of it, and it can run through it in seconds, and it can give you a pretty accurate, estimation or predictability of where your biggest issues or problems is lying. That's why, we're trying to also move away from paper, because although most of our processes and inspections and everything is digital, we still do rely on paper as well, which is not ideal, because from an audit perspective, it's always, where's this document, where's that document? And, to have everything in the cloud based, it's got pros and cons, obviously, from multiple risk-based perspectives. But yeah, for us, it's, to see what's world best practice. So if you look at what World Steel is doing, from our side as well, seeing that Qatar Steel is one of our brother companies, if we can put it like that. We did benchmarking missions toward, to go to them to see, what are we currently, what we're doing and what are they doing? And to say, because again, it might be some bigger companies and some older companies. We don't want to reinvent the wheel, but if we can improve the wheel by all we do that. And it's a lot of times you find things in different areas where, we overcomplify something, and then we can actually find something that's much more easier and, simplistic to use. And I think that's the main thing, especially dealing with different cultures and different behaviors. Seeing that our company is not just specifically just Algerian people working there. We have multinational people working in one complex. So we have to look at that perspective as well. So it's an exciting time. But I mean, I don't think from my experience that I've seen, there's one solution that fits all. I think everyone here, in the panel and everyone that's listening, each one will have pros and cons to a certain system. Being that from a safety perspective or being that even from a financial perspective. So it's to play around to see what works for your company and for a specific risk. And if it's implemented and it works correctly, then it's great. I mean, then you're doing what you're supposed to do.
Right. Thank you, Stephen. Dr. Paradeep, I have a question to you from the audience. If some of the companies need to start rolling out process safety management in their areas, what would be the first phase you would recommend? Not to overcomplicate things, but to build a strong, simple foundation to build on moving into the future.
Yeah, I can understand from where that comes from. Most of the companies having a structured HSE management system.
Mm-hmm.
Most of the things are already covered in the management system. Yeah, we're talking about specifically when it comes to process safety management, we're critically identifying certain activities that need to be in place to ensure the design integrity, the operating integrity, the mechanical integrity of the assets itself. So it's not just focusing only around systems and procedures to control accidents, but it is primarily about making the operational processes efficient, the assets, the integrity of the assets robust. So there are elements with respect to maintenance, respect to the design, respect to contract HSE management that gets added to the overall HSE management system. So it's very easy to adapt the existing. If a company has got an existing management system, we can pull out the elements from the process safety management into that and integrate it. I mean, if process safety is a major concern for that business, it's always good to keep it separately. If the process safety is a major concern, then it's good to have a separate process safety management system and separate HSE management system to handle the other, low consequence, high probability kind of scenarios. But if it is okay, you have too much of equipments, pumps, motors, generators, or you're handling extreme energies, then some elements can be embedded within the existing management system. I think the first step is always to do a requirement assessment and analysis. What process issues or what asset integrity issue that you want to manage or handle. Yeah, once you do that gap assessment, then you know what element needs to be pulled in and added to your existing management system. Yeah, so requirement assessment, then go ahead, do a gap analysis, then see what additional processes you must build in. It's important that process safety cannot be seen in isolation without taking care of the asset integrity. When you say asset, the plant, the equipment that you're using to process your raw materials into your products. So both go hand in hand. Only asset integrity and process safety has to be together. So there are even management system for asset management. We could follow that template, or our ISO 45001 template itself is good enough to, in the risk management element, you add the asset integrity process safety also part of it. Yeah. So you bring in all the HSE modelings and HSE impact assessment within that element.
Okay.
So start with a requirement assessment map, what your critical process safety areas are that you manage. Yeah.
Yes, thank you so much, Dr. Paradeep. I have now last question to all our speakers. Khaled, I'll start with you. Khaled, in one sentence, what does safety excellence mean in your organization?
The first priority.
Oh, beautiful. Stephen?
Yes, just repeat the question again.
In one sentence, in your organization, what does safety excellence mean?
It's such a good question. It's so simple yet so difficult to answer. I would say I can't say zero harm. I would love to say zero harm, but it's more strive to zero harm. I think it's more the striving section than the, it's easy for everyone to say zero harm, but in one sentence, to strive for zero harm.
Okay. All right. Thank you, Stephen. Dr. Pradeep, the same question to you.
Well, to me, what really separates you from rest of the industry is to have a sense of vulnerability always, not to be too complacent, not to get too used to the hazards and the safety issues around your place. The term that typically they use is chronic unease. You always be alert or active and actively or persistently keep focusing on the major safety areas in your place and never get complacency take over you. So probably once you have that mentality, then you will be mindful about the hazards around you, mindful about the barriers and its functionalities, and know what you need to do. So that builds in ownership, that builds in awareness, that builds in a constant state of detection, decision, and action. So you detect problems, you decide what to do, and you act on that. So for me, a sense of vulnerability people carrying in your company would be a sticking factor to change safety. Build safety excellence.
All right. Thank you, Dr. Pradeep. Ahmed, the question is also the same question to you. So what does safety excellence mean at EMSTEEL?
Thank you very much for the question, Manal. It's a great question. Actually, the safety excellence, it's meaning for EMSTEEL, it's one of the organization core value. It's a core value. Yeah. So that's what does mean. Yep.
Thank you. Thank you. Thank you, Dr. Karim. I've seen you raising your hand. Do you want to say anything?
Well, I didn't raise my hand unless I did it accidentally. But anyhow, I'm very happy to attend that meeting under your moderation, Manal. Well done. Thank you very much for your effort. And thank you, of course, for every speaker and for the audience being interested in this very nice and important topic of safety. We can never underestimate it. We can never just focus on production and just be happy producing steel. It's all about safety and how the people live safely every day, going back to their home and family. This is all about importance and core value, as Ahmed said. So I'm very happy of this webinar and the topic you chose, and wish everybody to also to be aligned with us for coming webinars. I don't know, Manal, if you are planning to announce next webinar or to say something about it or not, but I also leave it to you. Thank you, Manal, once again.
Okay. All right. Thank you, Dr. Karim. I want to thank all our speakers for those insightful presentations. Before we close, let me just highlight a few takeaways from today's presentation. Safety is about control, not just compliance. The strong barriers combined with culture drive effective risk reduction. Data must translate into actionable insights, and most importantly, leadership is critical to sustaining safety performance. With that, I would like to just announce the end of our today webinar. Thank you to our speakers once again for sharing their experience and for sharing their insightful presentation. And thank you to all the participants for joining us. We look forward to continuing this important conversation across the industry. Have a great day and stay safe. Bye-bye.